Arithmetic sequence. Un is said to be an arithmetic sequence for every n greater than or equals to 1. If un plus 1 minus un is equals to d, where d is a constant. D being a constant means d can be any numerical value, either 1, 2, 3, or any other. D is also called the common difference. Example, given un is equals to 3n minus 2 for every n greater than or equals to 1. Is un an arithmetic sequence? To find out whether un is an arithmetic sequence, we need to verify whether un plus 1 minus un is a constant. Un plus 1 is equals to 3 into n plus 1. So in the place of n, I'll put n plus 1 minus 2 is equals to 3n plus 3 minus 2, which is equals to 3n plus 1. But un is equals to 3n minus 2. Now, un plus 1 minus un is equals to 3n plus 1 minus 3n minus 2, which is equals to 3n minus 3n plus 1 plus 2, which is equals to 0 plus 3, that is 3. Un plus 1 minus un is equals to 3. 3 is a constant, therefore un is an arithmetic sequence. The general term of any arithmetic sequence is given by the formula un is equals to u1 plus n minus 1 times d, where u1 is the first term. That is, to get any term in an arithmetic sequence, we use this formula. Geometric sequence. A sequence un for every n greater than or equals to 1 is called a geometric sequence if un plus 1 over un is equals to r. R is a constant called the common ratio. Example, given un is equals to half the power n for every n greater than or equals to 1. Is un a geometric sequence? To find out if un is a geometric sequence, we need to verify whether un plus 1 over un is equals to a constant r. Un plus 1 is equals to half to the power n plus 1. And anyway I see n, I put n plus 1. But un is equals to half to the n. Now, un plus 1 over un is equals to half to the power n plus 1 all over half the power n, which is equals to half to the power n plus 1 minus n. From indices, n minus n is 0, which is equals to half to the power 1, which is half. Now, we have seen that un plus 1 over un is equals to a constant half. Therefore, un is a geometric sequence. For every n greater than or equals to 1, the general term of any geometric sequence is given by un is equals to u1 r to the n minus 1. That is, to get any term of any geometric sequence, we use this formula. Example, given un is equals to half to the n, where r is equals to half, u1 is equals to 2. Find u2. From the general formula to get the term of any geometric sequence, u2 is equals to u1 r to the 2 minus 1. That is, u2 is equals to u1 r. u1 is 2, r is half, that is 2 times half, which is equals to 1. It means u2 is equals to 1. Converging and diverging geometric sequence. A geometric sequence un for every n greater than or equals to 1 is said to converge if the limit of un as n becomes very large is equals to the first term all over 1 minus the common ratio, where the magnitude of the common ratio is less than 1. Sometimes the limit of un as n becomes very large is denoted s infinity. That is, s infinity is the same as u1 over 1 minus r. The sequence un is said to diverge if mark r is greater than or equals to 1. Recursive sequences. These are sequences that are always written in the form u0 un plus 1 is equals to f of un. That is, un plus 1 is always a function of un. Any sequence un for every n greater than or equals to 1 is recursive if limit of un as n turns to infinity is equals to limit of un plus 1 as n turns to infinity. For example, u0 equals to 8, un plus 1 is equals to un minus 2 over 3 is a recursive sequence because un plus 1 is a function of un.